See here, I'm starting the session. Listen. So in the previous session, we have seen control structures. See, you know all control structures except GOTO. Observe here. You know conditional control structures like if then else, if then else if, nested if, and case. You know looping control structures like simple loop, for loop, while loop, and you know jumping control structures like exit when, continue. Okay, these things you know. Last one is GOTO is there. So to execute the statements based on condition, we use conditional control structures. To execute the statements repeatedly, we use looping control structures. To terminate the loop in the middle of execution, use exit or exit when. Continues next iteration. To skip current iteration and continue next iteration, we use continue. Next one is GOTO. This GOTO is not that much important, but because of it is providing, you should know. So GOTO. See the syntax of GOTO. See, we write like this. So we write some statements. After that, we specify a label here. To specify the label, we have to use the symbols double less than, double greater than. In between that, specify one label name. So label means label is one identifier, like variable name, like procedure name. Okay, this label is also one identifier. Just we give one name. So in this, we write some statements. After that, here we are writing GOTO statement. GOTO. So after some statements, we are writing GOTO statement here. So when we are using GOTO, after GOTO, specify the label name. So GOTO, specify that label name. So this is the syntax we have to follow to use the GOTO control structure. So here we are writing some statements. After that, we are writing one label. After label, we are writing some statements. Then we are writing GOTO here. So when this GOTO statement is executed, so execution, when GOTO is executed, execution goes to this label and again executes this statement. So when GOTO is executed, you are telling that GOTO label. So it is going to this label and again executing the code. So again it is executing means it is acting like loop or not? Yes, it acts like loop. So once upon a time, when assembly language was there, starting versions of COBOL, Fortran was there. At that time, looping control structures were not there. So at that time, to execute the statements repeatedly, they were using this GOTO. After introduction of looping control structure, nowadays we are not using GOTO control structure. So GOTO purpose is executing the statements repeatedly. So looping control structures are also doing the same thing. Once upon a time, looping control structures were not there. At that time, we were using GOTO as the looping control structure. But nowadays, looping control structures are there. So that's why we are not using this GOTO. So GOTO means it jumps to a particular label and again executes the code. For example, see here. This is a program. So GOTO transfers the control to specified label. So we specify one label name To that label, execution will be jumped. Okay. So see one example program. This is a program to print numbers from 1 to 4. Program to print numbers from 1 to 4. This is our requirement. So 1, 2, 3, 4, like this we want to print. This is our requirement. So assume these values as I. Just a minute. So assume these values as I. Okay. So I'm writing the program here. Observe, declare, begin, end. So declare one variable I. I we are declaring. I we are declaring as number type, or you can also declare integer type. Okay, colon equals to I initial value I am giving as 1. At the time of declaration only I am giving the value. So I value is 1 now. That I value we want to print. So what we have to write? dbms underscore output dot put underscore line I. So what it prints now? 1 will be printed. After that we want to print 2. Okay, so we have to increase one value of I. So I plus 1. 1 plus 1, 2. The 2 value assigned to the I. So I value will become 2. Now I value is what now? I value is 2. This 2 value we want to print. So this 2 value we want to print means for printing again we have to write this statement. I value we have to print. So 2 will be printed. Okay, now here I value will become 3. 3 we want to print. So again this statement we have to print. Okay, I plus 1. I value will become 4. 4 we want to print. Okay, so when I value is equals to 4 or less than 4, we want to transfer the control to here. Again, we want to print I value. So execution should be transferred to here. So what I am writing is, I am writing GOTO control structure now. If I value is less than or equals to 4, then GOTO. So if I value is less than or equals to 4, again we want to print I value, then increase I value. So when I value is 5, stop. So GOTO, I'm giving label here. Okay, I'm giving label name as narrating. To close this if, I'm writing end if. So here we are writing the label, narrating label we are writing here. Narrating is the label. So to indicate this is the label, we are using double less than, double greater than symbols. So with double less than, double greater than symbols, Oracle understands this narrating is the label. Just like in the C language, after writing the label name, you are writing colon. Go to XYZ means that goes to this XYZ and executes the code. In the C language, to tell this is the label, we are using colon there. Like that. Here to tell this narration is the label, we are using double less than, double greater than symbols. In C language, we are using colon after the label name. To indicate this is label, we are using colon there. In the same way, this narration is the label to indicate that we are specifying label in the double less than, double greater than symbols. So when this GOTO is executed, execution jumps to this label and again executes the code. So this is the program to print numbers from 1 to 4. See the execution process, what is happening here. This is a program. For I, some memory will be allocated. Initial value of I is 1. Directly it executes the code. I value will be printed here. 1 will be printed. Next, I plus 1. Just a minute. Next, I plus 1. I value will become 2. Checks the condition here. I less than or equals to 4 is the condition. Okay, current I value is 2. Is 2 less than 4? Yes. Condition true. So GOTO statement will be executed. It goes to the nourish IT label and again prints I value. Now what is the current I value? 2. I plus 1. I value will become 3. Checks the condition. 3 less than 4. Is this condition true? Yes. GOTO will be executed. So when GOTO is executed, it goes to the nourish IT label. And again prints I value. I value 3. 3 printed. I plus 1. I value will become 4. Checks the condition. Is 4 less than 4? No. Is 4 equals to 4? Yes. 4 is equals to 4. Condition true. It goes to the label, prints I value 4. I plus 1. I value will become 5. Is 5 less than 4? No. Is 5 equals to 4? No. Condition false. Condition false means it comes out of the if. So GOTO statement not executed. So it terminates the program. And what is the output of this program? Observe here. 1, 2, 3, 4. So when this GOTO is executed, where it is going? To the specified label. We specified nourish IT label. So it is going to that label and again executing the code. It is acting like loop. I'm copying this. Observe. So this is the program. See here. What it is printing? 1, 2, 3, 4. It is printing. So without using the loop, using GOTO control structure, we are printing numbers from 1 to 4. So this code is executed repeatedly. So when GOTO is executing, it is going to this nourish IT label and again executing these two statements. Again, if this condition is true, it is going to the label nourish IT and again executing the code. So it is acting like loop here. So this is about GOTO control structure. Okay. So all control structures are over. Now see one example program, last program on control structures. With this program, control structures topic will be over. Next I start the new chapter, cursors. So there is a table. This is a program to calculate total marks, average marks, and result of given student ID. And insert the result in result table. So there are two tables are there. First table name is student. It has fields like SID, S name, marks of subject 1, marks of subject 2, marks of subject 3. In this data is there. So like this some data is there. So this is student table. We want to create one more table, result table. In the result table, we are maintaining the student total marks, student ID, student total marks, average marks, and result. Pass or fail, we want to print. So student details are in which table? Student table. With our program, we want to read SID value. If I give SID value as 1001, that has to calculate 1001's total marks. Means 60 plus 80 plus 70. And that has to calculate average. Means 60 plus 80 plus 70 by 3. And that has to find the result. In every subject, he must get 40 or greater than 40, then pass. Otherwise, fail. So we are finding total, average, and result. After finding total, average, result, insert that result into this result table. So student ID is 1001. Is total marks means 60 plus 80 plus 70 value. 60 plus 80 plus 70 by 3 value. Okay. So is result pass or fail? We want to insert here. This is our requirement. So this is the program to find result of the student. We are finding total marks, average marks, result, and we are inserting into result table. We are working with two tables here. From one table, we are taking the input. Result we are storing in another table. So first create these two tables. Tables are not ready. Create these two tables. So let me check. Student table, maybe it is there. Check. So when we discussed about if control structure, nested if, we have created this table. Student ID, student name, marks of subject 1, marks of subject 2, marks of subject 3. Observe here. First student result is pass. Second student result is pass or fail? Fail. So how you are telling result is fail? In second subject he got less than 40. Less than 40 means fail. In every subject student must get 40 or greater than 40 then pass. In any subject student is getting less than 40 means fail. So if we give student ID 1001, that has to find 1001's total marks, average marks and result, and that should be inserted in the result table. If we give 1002, 1002's total marks, average marks and result, that has to find. For that we have to write the program. So result table is not ready. Let me create result table. So table name is result. So we are creating result table here. So create table. Table name is result. Student ID, number type, total marks. Okay, number type. Okay, average marks. Okay, I am giving number of 5,2. Okay, next result. Result varchar 2 of 10 I am giving. So now table will be created. Result table will be created. So observe here what it is telling. Table created. So now open and see the table data. Select star from result. So in the result table is created. No rows are there. Okay. So now we want to give one student ID. That program has to calculate total, average and result, and that has to insert record into this result table. That is our requirement. So we are writing the program now. Okay. Observe. Declare. Begin. End. Okay. Now we want to read student ID first. So v underscore SID variable I am taking. Colon equals to ampersand SID. So we want to declare this v underscore SID variable. So v underscore SID, which table variable? Student table, student ID type. So student dot SID percentage type. Okay. Now we have student ID. What we have to do? We want to calculate total marks. So to calculate total marks, if for example, we are giving student ID as 1001. So what we have to calculate? 1001's total marks we have to calculate. So this 1001 entire row, I am holding in one variable R1. Now R1 is percentage row type. R1 variable we are taking as which type? Student percentage row type. In the R1 we are holding that row SID, SNAME, M1, M2, M3. So 1001 if we are giving, here this entire row will be stored into the R1. So 1001, A, 60, 80, 70. We want to calculate total marks. To calculate total marks, how can we access this value? R1.M1. Good. R1.M1. Okay. So what we have to write here? R1.M1 plus R1.M2 plus this value. R1.M3. So where we want to store, listen. This result table row we want to hold. Because we want to hold total average result. So I'm taking one more variable, R2 variable I'm taking. Okay, this R2 is which type? Result table percentage row type. So R2 holds, okay, entire row of result table. So R2 contains SID, R2 contains total, average, result. Okay, now where we want to store this total marks? Here. Where we want to store? R2 dot total. So what we have to write here? R2 dot total colon equals to R1 dot M1 plus R1 dot M2 plus R1 dot M3. Okay. So we want to calculate the total marks. So marks are in the student table. So the student table row we are holding in the R1. R1 dot M1 plus R1 dot M2 plus R1 dot M3. We are holding this result table row in the R2. So R2 has SID, total average result. So in the R2 dot total, store this result. 60 plus 80 plus 70 value. 60 plus 80 value is what? 140. 140 plus 70, 210. The 210 value will be stored here. R2 dot total value is 210. 210. Okay. Next, we have total marks. Can we calculate average with this total? Yes. So what we have to write? R2 dot total by 3. Where we want to store it? R2 dot average. So R2 dot average colon equals to R2 dot total by 3. Means 210 by 3. Okay. 3 7 21. So 70%. 70 average. Next it finds the result here. So find the result. To find the result, you already know. If control structure we have to use. Okay. R1 dot M1 value must be greater than or equals to 40. And R1 dot M2 value must be greater than or equals to 40. And R1 dot M3 value must be greater than or equals to 40. Okay. Then, if this condition is true, then this value, this is what R2 dot result. R2 dot result colon equals to pass. Else, R2 dot result colon equals to fail. Like this we calculate. Did you get some idea? Now we are writing the program. So to hold the student record, take one variable R1. To hold the result record, take R2. So student table row we want to hold. So student percentage row type. R2 is result percentage row type. Okay. So now retrieve the data from the student table. Given student ID's data we want to retrieve. So all columns data we want. What we are writing? Star into. Select star into R1. From which table? Student table. Where student ID equals to V underscore SID. So one student's record we are retrieving. Given student ID record we are retrieving and we are holding in the R1. So what happens here? Here R1 will be created. Observe. See here. Here R1 is created. So what R1 is having? R1 is having student ID, student name, M1, M2, M3. For example, we are giving student ID as. So we are giving student ID as 1001 at runtime. So now V underscore SID value is what now? V underscore SID value is 1001. So 1001 student record will be retrieved that record will be copied into the R1. Now R1 has 1001 record. If we give student ID as 1001, V underscore SID value 1001, 1001 student record retrieved and copied into the R1. R1 has one row of student table, 1001 record copied into R1. Now we want to calculate total. So to calculate the total, okay, we want to calculate the total now. So to calculate the total, we have to access this value. So what we have to write? R1 dot M1. To access this value, R1 dot M2. To access this value, R1 dot M3. So R1 dot M1 plus R1 dot M1 plus R1 dot M2 plus R1 dot M3. This value where we want to store, we have taken R2 variable here. So R2 variable is created like this. So this is R2 variable. This is R2 variable. This is R2 variable. So this one is the R2 variable created. Here in this R2.tot, we want to store this total marks. Okay, so what we have to write here? R2.total colon equals to R1.M1 plus R1.M2 plus R1.M3. So now we will get total value here, 210 we will get. Okay, next we want to calculate this average. So what we have to write here? R2.average colon equals to our total marks we have already we have. Total marks already we have. So directly write R2.total by 3. So here we will get 70. 70 average value we will get. Next we want to find the result now. So to find the result, what we have to write? If, okay, M1 marks must be 40 or greater than 40. M2 marks must be 40 or greater than 40. M3 marks must be 40 or greater than 40. In every subject, he must get 40 or greater than 40, then result is pass. What we write? R1.M1 greater than or equals to 40 and R1.M2 greater than or equals to 40 and R1.M3 greater than or equals to 40. Then okay, then pass value we want to hold. Where we want to hold? In the R2 dot result here. Here we want to hold. Okay, so in the R2 dot result we want to hold. So write R2 dot result colon equals to pass. Okay, this condition false means what? Else R2 dot result colon equals to fail. So fail value will be stored. Okay. Now what we have to do? We have result in the R2 now. So this student got in all values are greater than 40 here. So result is pass. So this data where we want to hold, where we want to insert in the table, in the result table. So here result table is there. In the result table, SID total, average, result. In this result table, we want to insert the record now. So student ID we have given. Student ID is in which variable? Student ID in which variable? V underscore SID. So here we have to insert V underscore SID value. This total marks in which variable? R2 dot total. R2 dot total. So what we have to write here? R2 dot total. Insert into result values V underscore SID, comma R2 dot total, average value in R2 dot average. So R2 dot average. Okay. This is R2 dot result. R2 dot result. So these values we have to insert in the result table. So we are writing like this. Insert into. Okay, in which table we want to insert? Result. Okay, values. values. So student ID we have given, so v underscore SID. Okay. Next, total marks are in R2 dot total, R2 dot total value. Okay. Average marks are in R2 dot average, and result is in R2 dot result. Those values we are inserting in the result table. So program is over. So this is a program. Just a minute. So this is a program to find total marks, average marks, and the result of the student. Okay. So what we are doing, observe here. Here we are reading the student ID. That given student IDs, marks details, we are holding in the R1. So now R1 has M1, M2, M3 data. So we are calculating total here, and we are storing in the R2 dot total. Here we are calculating the average. We are holding in R2 dot average. After that, we are finding result. In every subject, student must get 40 or greater than 40. Then his result is pass. If this condition true, R2 dot result value will be pass. If this condition false, R2 dot result value will be fail. Finally, we are inserting the result into the result table. Okay. So after inserting the record, we want to save the transaction. To save the transaction, what we are writing? Commit. For user understanding purpose, we are displaying one message, dbms underscore output dot put underscore line. Okay. So result calculated and inserted in table. Result calculated and inserted in table. Result calculated and that result inserted in the table. Okay. So these last two lines I'm copying here. So finally, this is the program. Okay. So program is over. Tables are also ready. Now observe now. See, as of now, result table is not having any records, no rows selected. We are compiling and running the program. So I am giving this student ID 1001. Okay. So 1001 result it finds. 60 plus 80 plus 50 value it finds. So 60 plus 80, 140, 140 plus 50, 190. According to this example, 190 here. So 80 plus 60, 140, 140 plus 50, 190. Okay, so student ID I'm giving as 1001. What it is telling? Result calculated and inserted in table. Inserted or not, open and see the table. Select star from result. See here, 190 total, average 63.33, pass. Previously, select star from result means it was telling that before running our program, it was telling that no rows selected. After running our program, now this result table has 1001 record. Okay, this is a way of calculating result. So from one table, we are capturing the input, and that result we are storing in another table. With two tables, we are working. So in the same way, I want to calculate 1002's result. So I'm running the program here. So this is a program. Student ID I'm giving us 1002 now. Result calculated and inserted in table. Open and see the table data. Select star from result. Observe here 1002 total marks 170 is result is fail. 1002 result is fail. Okay, because this 1002 in second subject he got 30 marks only, less than 40. So his result is fail. So what is happening here? Observe. See, this is a program. See here. Here it is asking student ID. We are giving student ID as 1001. This 1001 will be stored in the V underscore SID. What is V underscore SID value now? 1001. So here 1001 student record will be retrieved and that entire row will be copied into the R1. So R1 is holding, see here, R1 is holding 1001 record. Next R1.M1 means 60. R1.M2 means 80. R1.M3 means 70. So 60 plus 80 plus 70 result will be stored in the R2.total. In the R2.total it is storing. Next R2.total value 210 by 3. That result will be stored in the R2.average. So we are getting average. Next, using if control structure, we are finding the result here. In all subject, student got greater than 40. So result is pass here. This condition true. Okay, so 60 greater than 40 condition true. 80 greater than 40 condition true. Okay, and 70 greater than 40 condition true. So all conditions are true and should satisfy all conditions. So all condition is true. R2 dot result value is pass. Okay, so after that it is coming out of the if else. It is executing this insert statement. V underscore SID value is 1001. Okay, next R2 dot total 210. R2 dot average 70. R2 dot result pass will be inserted into this result table. Here those values will be inserted. And finally data will be saved in the Oracle database and it displays message as result calculated and inserted in table. This is the program. So is it clear? So this is about control structures. Complete control structures topic is over. So how many categories of control structures are there? 3 categories. What are those? Conditional control structures, looping control structures, jumping control structures. So these conditional control structures execute the statements based on the condition. If you want to perform one task based on condition, use if then. If you want to perform any one of 2 tasks, use if then else. If you want to perform any one of more than 2 tasks, then use if then else if. Nested if you want to write if in another if, use nested if. When outer condition is true, then only that should check another condition. At that time, use nested if. This case we can use in 2 styles, simple case, searched case. Simple case can check equality condition only. Searched case can check any type of condition. And looping control structures, to execute the statements repeatedly, we use them. Next, jumping control structures, to terminate loop, use exit or exit when. Okay, to execute the statements repeatedly, we can use GOTO. Okay, GOTO means it goes to the specified label. Here we specify the label name that goes to that label and again executes the code. Continue skips current iteration and continues the next iteration. Okay, so this is about control structures. Control structures topic is over. And next topic is topic name is, just a minute. So next chapter name is cursors. Topic name is cursors. So pay attention and listen carefully here. If you don't listen, you cannot understand. So listen carefully. Cursor. So what is cursor actually? See here. Listen. For example, you tell me, listen carefully. So select star from EMP. My requirement is I want to hold employee salary. This is my requirement. Only one value. I want to hold employee salary. This is my requirement. I want to hold employee salary. Okay. So we have to take one variable. That variable we have to take as which type? Our requirement is what? We want to hold one value. Listen carefully. Our requirement is holding one value. One salary column value we want to hold. Which data type we have to use? Which data type we have to use? Percentage type. Okay. So what we are writing? EMP dot salary percentage type. So how you are declaring V underscore salary? EMP dot salary percentage type. So what is the purpose of percentage type? To hold one column value, we are using percentage type. Now our requirement is, okay, to hold this one salary value, we are taking one variable, V underscore salary. We are declaring this as EMP dot salary percentage type. So now V underscore salary can hold how many values? One value only. What is that one? 9,960 that holds. My requirement is I want to hold entire row. Okay. So what we have to use? Row type we have to use. EMP percentage row type. Okay. R EMP percentage row type. Now R can hold what? R can hold employee number, name, job, salary, all 8 columns. So 8 values it can hold. How many values it can hold? 8 values. 8 values it can hold. But how many rows it is holding? 1 row. Okay. Can row type variable hold multiple rows? No. Row type variable can hold only 1 row at a time. But my requirement is I want to hold multiple rows. To hold the multiple rows, we have to use one concept. That concept is what? Cursor. Cursor is used to hold multiple rows. Row type can hold only 1 row. Okay. Just now we have written one program. This program we have written. Observe. Observe carefully. This is the base point here. So by using this program, by running this program at one time, we are calculating result. By running this program at a time. Just a minute. So by running this program at a time, how many students result we are finding? Only 1 student. By running this program at a time, okay, we are finding result for only 1 student. For example, assume that in the student table, 100 student records are there. Now, how many students are there? 100 students are there. I want to find result of 100 students. But if you use this program can calculate result for how many students? 1 student. We want to find result for how many students now? 100 students. How many times we have to run our program? 100 times. So it is becoming complex to us. So every time running the program, giving student ID means it is becoming complex for us. See, just now we have seen this program. So first time we calculated. So initially in the result table, no rows were there. After running this program for first time, we are giving 1001. 1 student result calculated. That stored in the result table. 1 record inserted. I want to calculate result of second student. Second time we are running the program. Second student result we are finding. Second student result inserted in the result table. So to find the result for 2 students, we run this program for 2 times. Tomorrow, if you want to find result for 100 students, if we follow this way, 100 times we have to run the program, it becomes complex. So to process multiple rows in such type of situations, to process multiple rows, don't follow this way. We have to use one concept, cursor concept. To process multiple rows, use cursor concept. That is the purpose of cursor. Okay. So see here. For example, we want to hold one salary value. To hold employee's salary value. Okay, means one column value. So to hold employee's salary value, which data type we are using? Percentage type. Okay. To hold employee row. To hold employee row, which type we are using? Percentage row type. Okay. I want to hold all employees rows. To hold all employees rows. Okay. All employee records. I want to hold all rows. Multiple rows. To hold multiple rows, which concept we have to use? Cursor. Okay. To hold one value, percentage type. To hold entire row, percentage row type. To hold all rows, cursor. To hold multiple rows, we use cursor. Okay. Below I am writing. Percentage type is used to hold one column value. Percentage row type is used to hold one row of a table. Then cursor is used to hold multiple rows. If our requirement is holding multiple rows and processing one by one row, we use this cursor concept. So actually, what is this cursor here? So cursor means you can understand like cursor is a pointer or reference. Cursor is a pointer to memory location. Cursor is a pointer to memory location of Oracle instance. Memory location of Oracle instance. So it is a pointer to memory location of Oracle instance. Oracle instance will be stored in which location? RAM. So it is a pointer to the memory location in the RAM. You can understand like cursor is a pointer to the memory location of Oracle instance. So this memory location holds multiple rows. Okay, so this memory location holds result of select query. This memory location holds multiple rows. So that's why we are saying cursor is holding multiple rows. So cursor is a pointer to the memory location of Oracle instance. This memory location is holding multiple rows. Okay. So now to use this cursor, so it is one pointer or you can say reference to the memory location of Oracle instance. So every cursor is associated with one select query. So cursor is associated with, mapped with or linked with, cursor is associated with select query. Okay, this select query result will be stored in the Oracle instance. So when select query is submitted to Oracle, to Oracle, okay, the result will be the result of select query will be copied into the result of select query will be copied into Oracle instance. So this memory location address will be given to the cursor. This memory location address will be stored in cursor variable. So that's why, so what cursor variable is holding? Cursor variable is holding address of memory location of the Oracle instance. So that's why we are calling cursor is a pointer, or you can say reference. It is not holding data, it is holding address. Cursor variable is holding address. Just like in the previous program, if you see here, this V underscore, for example, last program, today we have written this V underscore SID. V underscore SID is the variable. This variable is holding data. Whereas our cursor variable, what it holds? It holds address. It holds address of some memory location. This memory location has multiple rows. This is the memory location of the Oracle instance. So normal variable holds what? Data. Cursor variable holds what? Address, pointer. It is a pointer to the memory location in the Oracle instance. Okay. So every cursor is associated with one select query. Observe. See here. Let me explain clearly. I'm giving overview here. Observe. So this is database server, Oracle server. This is Oracle server. So Oracle server contains two parts. One is Oracle database. Another one is Oracle instance. So this is Oracle instance. And this one is the Oracle database. So this is Oracle database. This is Oracle instance. So where this Oracle instance is stored? In the temporary memory, RAM. Where this database stored? In the permanent memory, hard disk. So here EMP table stored here. Okay, assume that this is our PLSQL program. This is our PLSQL program. So this is our cursor. This is our cursor. This is our cursor. Cursor variable name I am giving as C1. So every cursor is associated with one select query. So when we run this program, one select query will be submitted to the Oracle. So when we run this program, okay, one select query associated with the cursor. So for example, that select query, assume that select star from EMP is the select query. Select star from EMP, for example. Okay, select star into so and so from EMP. So this is the select query we are submitting to the Oracle. So when this PLSQL program is running, every cursor is associated with one select query. So this select query will be submitted to the Oracle. So Oracle runs this query. So it goes to the Oracle database, picks the data and copies into the Oracle instance. That select query result will be copied into the Oracle instance here. So this is Oracle instance. So here that select query result copied. Like this is employee number. Okay. Next employee name, job, salary, like this. Rows and columns are copied into the Oracle instance. So in the Oracle instance, like this, rows and columns are copied. So now, this is the memory location. Observe carefully. This is the memory location in the Oracle instance. It is holding multiple rows. So this memory location address will be given to the C1. So now C1 is holding this Oracle instance memory location address. So this memory location is having multiple rows here. This is select query result. Multiple rows are there. Okay. So at a time it fetches one record. That record will be processed. Next fetches another record. That record will be processed. Next fetches another record. That record will be processed. Like this. So here what cursor is holding? Address of this memory location. So C1 is a pointer to the memory location in the Oracle instance. So C1 is the cursor. This C1 is the cursor. This cursor is a pointer to the memory location in the Oracle instance. So when cursor is opened, this select query will be submitted to the Oracle. So Oracle goes to the database, picks the data, result will be copied into the Oracle instance. So this memory location address will be given to the C1. So now C1 is pointing to memory location in the Oracle instance. So C1 is holding multiple rows. To hold multiple rows and process row by row, we are using this cursor concept. So to hold multiple rows and process row by row we use cursor concept. So this is the purpose of cursor. So what is cursor? It is a pointer to the memory location which is in the Oracle instance. So every cursor is associated with one select query. So when we open the cursor, select query will be submitted. That select query result will be copied into the Oracle instance. That memory location address will be given to the cursor variable. So cursor variable is holding address of some memory location of Oracle instance. So you can say cursor is a pointer to the memory location of Oracle instance. So what that memory location is holding? Multiple rows. So you can say cursor is holding multiple rows. So every cursor is associated with select query. When select query, so when we open the cursor, select query will be submitted to Oracle. The result of select query will be copied into Oracle instance. This memory location address will be stored in the cursor variable. So you can say cursor is a pointer to the memory location in the. So did you understand this point? Okay. So now listen. To use the cursor, we have to follow 4 steps. To use the cursor, okay, we should follow 4 steps. 4 steps we have to follow. What are those? So topic name is steps to use the cursor. So if you want to use the cursor, we have to follow 4 steps. What are those 4 steps? First step is declare the cursor. Second step is open the cursor. Third step is fetch the record from cursor. Fourth step is close the cursor. These 4 are important here. And we must follow this order. Okay, we must follow this order. First declare, then open, then fetch, then close. You cannot change the order here. Okay, so I want to write fetch statement first, then I open the cursor. No, it is not possible. So first open the cursor, then fetch the records from cursor like this. So we have to follow this order. 4 steps we have to follow. Declare the cursor, open the cursor, fetch the record from cursor, close the cursor. 4 steps. So first step is what? Declaring cursor. So declaring cursor. So to declare the cursor, we have to follow one syntax. The syntax is, in the declaration part, write like this. Cursor, give the cursor name. Cursor variable name we give. Cursor variable name we give. Then write is, I already told, every cursor is associated with one select query. So which select query you want, that select query we have to write here. Every cursor is associated with one select query. Here we write like this. Cursor C1 is select star from EMP. Like this we are writing. So for this C1 cursor is associated with which select query? Select star from EMP. So this is the syntax we have to follow. This is the syntax for declaring the cursor. So cursor variable name is, write any select query. You already know about select query. Any select query we have to write. And here select query syntax we follow of SQL syntax, not PLSQL. Okay. And we write like this. Observe here, cursor C1 is select ename, salary from EMP. So in the previous sessions, we have written this program. Observe here. This program we have written. So here what we are doing, observe. We are reading one employee number. That employee's record will be retrieved. Employee name will be copied into V underscore E name. Salary will be copied into V underscore salary. Hire date will be copied into V underscore hire date. So V underscore E name, V underscore salary, V underscore hire date, it is printing. So we are giving employee number here. That employee's record it is printing. So how many employees records we are retrieving here? One record, one employee record. For example, I want to retrieve 100 employees records. So if we want to use this program, how many times we have to run this program? 100 times. Okay. So using this program, we can retrieve only one employee record. That one employee record we can display. That's it. But my requirement is I want to display all employees records. To work with multiple rows, we have to use cursor concept. So that's why we are using the cursor here. So cursor variable name we are giving as C1 is, write one select query we are writing. So with this what happens, sir? When we declare the cursor, this C1 cursor variable will be created. And that identifies which select query is there with this cursor. That's it. So when we declare like this, what happens here? So when we declare the cursor, okay, cursor variable will be created. And Oracle identifies, cursor variable will be created and identifies select query associated with it. So cursor variable will be created and identifies select query associated with the cursor. So which select query is there with the cursor, that will be identified. That's it. So what happens here with this declaration? One C1 variable will be created to hold some address. This variable is created. And every cursor is associated with one select query. Which select query is there? Just this select query will be identified. This step will be happened when we declare the cursor. So in the declare part, we declare this cursor. Okay. So declaration first step is over. Okay, we declared. But now we want to work with multiple rows. So to work with multiple rows, first we have to submit this select query. First we have to submit this select query to the Oracle. So to submit select query to the Oracle, we have to follow another step. Second step, what is that one? Open. Opening cursor. Opening cursor. Cursor has to be open. Okay. So what is the syntax we have to follow? Observe here. Very, very simple. Open. Give the which cursor you want to open. Give that cursor name. Okay. So for example, we are writing like this. Open. Our cursor name is C1. So when we open the cursor, what happens here? When we open the cursor, okay, select query. Select query will be submitted to Oracle. Select query will be submitted to Oracle. So Oracle runs select query. Okay. And result of select query will be copied into Oracle instance. Result of select query will be copied into Oracle instance. And this memory location address. So select query result copied into this result of select query will be copied into Oracle instance. So that memory location has multiple rows. So this memory location address will be given to cursor variable. So now cursor holds reference. Cursor holds address. So now cursor holds reference of memory location which is in the RAM. Cursor holds reference of memory location of Oracle instance which is in the RAM. This thing will be happened. So I'm explaining clearly. Listen. Now two steps you know. One is declaring cursor. Another one is opening cursor. So observe carefully. So to declare the cursor, how you are writing? You are writing like this. Cursor C1 is select ename, salary from EMP. Like this we are declaring. So when we are declaring like this, what is happening? C1 reference variable will be created. And it identifies which select query is there. Okay, this select query will be identified. That's it. Next, second step, we are opening the cursor. So when we are opening the cursor, now our cursors is associated with one select query. That select query will be submitted to the Oracle server. The server is having database and Oracle instance. So it goes to the database, picks the data from EMP table, employee names and salaries will be copied into the Oracle instance. This memory location address will be given to the C1. Now C1 is pointing to this memory location. That's it. So now cursor is holding multiple rows. Okay. We need to process row by row now. We want to work with records now. To process the rows, to process row by row, we have to use next step. The third step is what? Fetch. So when we declare the cursor variable is created and identifying the select query. When we are opening the cursor, okay, select query result will be copied into the Oracle instance. That memory location address is in the C1 now. Now C1 has multiple rows. We want to process row by row now. To process row by row, we have to follow third step. What is that one? Fetching records from cursor. Third step is fetching records from cursor. So we have to follow this syntax. So fetch. From where we want to fetch? From C1 cursor we want to fetch. Okay. And that we want to hold in some variables. So here we have to specify the variable list here. Variable list we specify. So we are fetching record from cursor. That record data we are holding in the corresponding variables. For example, see here. So this step is important here. For example, we are writing like this. Fetch this is cursor name, not C1. So fetch cursor name. Fetch cursor name into variable list we have to give. So this is the third step we have to follow. Fetch cursor name is C1 into, okay, we are taking variables to hold the employee name, V underscore E name, to hold the salary, V underscore salary. Okay. So now listen carefully. This step is important. One fetch statement can fetch only one record at a time. One fetch statement can fetch or select. Fetch means what? Select. One fetch statement can fetch only one record at a time. So to process multiple rows, write fetch statement in the loop. Write fetch statement in loop. So one fetch statement can process one row at a time. Okay, to process multiple records or multiple rows, okay, write fetch statement in loop. So one fetch statement fetches one record only. To process multiple records, multiple rows, we have to write fetch statement in the loop. Okay. So now see here, I'm explaining clearly, listen. So when we declared the cursor, one cursor variable created. So this cursor is associated with one select query. And when we open the cursor, this select query is submitted to the Oracle. E-name salary from EMP. So when we open the cursor, this select query will be submitted to the Oracle. So this Oracle server is having Oracle database and Oracle instance. So it goes to the EMP table, picks the data and copies into the e-name salary will be copied into the Oracle instance. Like 1001, 1002, employee names, right? Names and salaries. Okay. Employee name Smith is salary. Employee name Allen, salary. Okay. Ward, salary. So this memory location has multiple rows now. So this memory location address will be given to the C1. Okay. So is it clear till here? When we declare the cursor, this cursor variable created, select query identified. When we open the cursor like open C1, means this select query is submitted to the Oracle. Oracle is going to the EMP data and copies select query result into the Oracle instance. This result given to the C1. So now C1 is pointing to the memory location in the Oracle instance. So now we need to process row by row. Okay. So here in the Oracle instance, employee names are there and salaries are there. Observe. For example, employee name A, salary. Employee name B, salary. Employee name C, salary. Like this data is there. This data stored in the Oracle instance. So this memory location address is in the C1. So this C1 is holding this memory location address. So C1 is a pointer to the memory location in the Oracle instance. Okay. Now, this C1 has multiple rows. So by default, it will be, if 3 rows are there in the memory location, there will be 2 extra rows will be there. One row is before first row and another row is after last row. Okay. So one is before first row and another one is after last row. So first time cursor will be pointed to the, this cursor will be pointed to the before first row. This cursor will be pointed to the before first row. Okay. So when fetch statement is executed, when fetch is executed for first time, so now fetch is executing. When fetch is executed, it goes to the first row now. So how you are writing fetch statement? Observe here. Fetch C1 into V underscore ename, comma, V underscore salary. So when fetch statement is executed for first time, in the V underscore ename, that copies this ename value. In the V underscore salary, it copies salary value. So first record fetched here, this record copied into the corresponding variables. So now we print this data. One row, one record we accessed. So now write this fetch statement in the loop now. Okay. So again, fetch statement will be executed. When it is fetching, it goes to the next row again. So again, second time fetch is executed. So it is fetching second row here. Now second row will be copied into the, now C1 means second row. Second row will be copied into the corresponding variables. So here in the V underscore ename, what it holds now? B. Then what it holds? 4000. Okay. So again, to process third row, again we have to execute. Is executed, it goes to next row. This next row will be copied into the V underscore ename. So V underscore ename value C and salary value is 6000. So 6000 will be copied here. Again, fetch statement will be executed. After this, no row is there. So when no row is there, stop. Stop when record not found. That's it. This is a way of working with multiple rows. So we need to execute fetch statement for multiple types because one fetch statement can fetch only one row at a time. After working with this row, fetch another record. After working with this row, fetch another record. So if record is not found, stop. All rows are processed. So finally our work is over. We worked with all rows here. All employees records we displayed. Finally, last step is what? We have to close the cursor. To close the cursor, what we have to write? Closing cursor. So to close the record from cursor, to close the cursor, what we write here? We write close, give the cursor name here. Close and give the cursor name. close and give the cursor name here. So the example is we want to close C1 cursor. So right, close C1. So when close is executed, what happens here? So when we close the cursor, reference to memory location will be gone. Reference to memory location will be gone. Means we cannot work with those rows now. So here, this C1 is pointing to this memory location. This is reference here. This reference will be closed. This connection will be closed. So now you cannot access these rows now. Okay. So total how many steps we are following? 4 steps. Okay. So what are those? First one is declaring the cursor. So we are declaring like this. If we declare like this, what is happening? C1 variable will be created. Select query will be identified. Okay. Next, second step is what? Opening the cursor. Open cursor name. When we open the cursor, what is happening? Select query will be submitted to Oracle. Oracle runs select query. Result will be copied into Oracle instance. That address will be given to the cursor variable. Next, we need to work with the fetch statement. We have to fetch the records. So by default, cursor is pointing to before first row. When fetch is executed for first time, it goes to first record. That first record will be copied into the variables. We work with this data. After that, fetch another record. Again, when fetch is executed, next record will be accessed. Again, when fetch is executed, next record will be accessed. We work with this one. Okay. So after that, when record is not found, stop fetching. So like this, we work with multiple rows. Okay. At a time, it can process one row. So to hold multiple rows and process row by row, we are processing first row, then second row we are processing, then third row we are processing. Like this, row by row we are processing. To hold multiple records and to process row by row, use the cursor concept. Finally, we are closing the cursor. To close the cursor, we are writing close C1. So just this is theory concept. I'm stopping the session here. In the next session, by following these 4 steps, we write number of programs on cursor. So most of the examples I cover in the next session. Okay. So maximum, I try to finish this cursor topic in the next session. Okay. Thank you everyone. See you tomorrow. Okay. Online students, if you have any queries, you can ask. Please type in the chat box. Regarding cursors, if you have any queries, you can ask. Okay. Kaivalya, all topics are important. Okay. I didn't prepare any interview questions. All are important only. Just to go through the notes. Okay. Twinkle. Okay. Create is the DDL command. Twinkle. Create is the DDL command. So when I started PLSQL, there I have given one statement. Okay. What is that statement? DML commands, DRL commands. Observe this statement, Twinkle. DML commands, DRL commands, TCL commands. DML commands means insert, update, delete. DRL means select. Okay. TCL means commit, rollback, save point. These we can use directly in the PLSQL program. But DDL and DCL commands, we cannot use directly. So create is the DDL command. We cannot use directly. we have to use dynamic SQL concept. Using dynamic SQL concept in the PLSQL program, you can create the table, you can alter the table, you can truncate the table, you can drop the table. This DDL, using dynamic SQL, that part I cover in the dynamic SQL. Okay, Manoj, if you are unable to put efforts, if you are unable, okay, then you are not eligible to be in the IT field. I will not encourage interview questions, important questions. I will not encourage such kind of things. All are important. If you are unable to do that much work, if you are unable to refer the notes, means you are not eligible to be in IT field. Okay, if you have, you can refer. Okay, thank you everyone. I'm leaving the session. For single user or multiple users, we use revoke only. Ashutosh, revoke all means, here all means select, insert, update, delete, not all users. So after to class, you are giving the username. Okay. So for revoke from class, we use. So revoke all on EMP from. After from, you are giving username. After from, you are giving one username means after user, after one user. After from, if you are giving one user means it cancels permissions from one user. After from, if you are giving multiple usernames means it is cancelling permissions from multiple users.